So, hello everyone, and welcome to this online session that we conduct every weekend. Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to steel or RCC design concept or construction site issues or any project that they are doing. So, this is the 42nd such episode that we are conducting, and let us begin by taking the questions from the uh, Google form. So first, as we all always do, we will take the questions from the Google form, and then we will take the questions from live comments. So let me just open this screen. Yes, and the first query is from. I hope the voice is audible properly. So first query is from Amok Deshpande from Nagpur. He is a postgraduate student, and he is saying his question is, while modeling a floating column in STAD or ETABS, how to ensure that no lateral it is not a lateral load resisting element and it only takes gravity loading. So the simplest way to do this will be, suppose I make a frame. So let's say in elevation, this is a beam, this is a column, okay, and I'm drawing an elevation, and then we have a beam level over here. Now let's say these columns are getting continued. So what's happening? This is a gravity, sorry, this is a floating column, let's say. It's not getting continued below. So this is a floating column. Now, as per the IS 1893 requirement, it cannot be part of your lateral load resisting system. If a column is a floating column, it cannot be part of lateral load resisting system. So the question now over here is how to ensure that it is not a lateral load resisting element and only takes gravity loading. So the simplest way to ensure this will be that when you are designing these beam elements, try and have it try and model these beam elements with end releases over here. So when you will model end releases, what will happen? Only shear force will be transferred. No moment will be transferred. And since no moment is transferred, it will automatically behave only as a gravity column even under the effect of lateral load. So if lateral load also comes, because you have provided end releases over here, no moment gets transferred to the column or no axial load from this lateral load gets transferred to the column, and I can call it as a gravity column therefore. And then you design and detail this connection as a shear connection only. Ensure that the reinforcement is not developed. Just give reinforcement slightly till LD by 3 and curtail it. Do not design this end as a continuous beam. So keep these two ends as shear connections only. And then the reinforcement also, as I just told, should be developed only till LD by 3. So by doing these things, you can sort of ensure that the column only takes gravity loading even under the effect of lateral loads. Okay. Yeah. So this was his first question. Second question is, can we rely on reinforcement values in ETABS and STAD, or is it recommended to check manually? See, each of these software have their own bugs. ETABS also sometimes take some funny values in design. STAD also commits some mistakes in slender columns. ETABS commit some mistakes in beam calculation sometimes when it is doing doubly reinforced checks. So there are some problems with these software. Uh, and so always what you should do is that I always try to see what ETABS or STAD or any software is giving, and just try to do quick cross checks manually also. Okay, so this is my personal approach. That so first of all, I will always verify the software. Thorough verification of the software is suggested, so that you can build confidence of the software, understand what it is doing. Then, when you start using the software for your project work, then also you should at least see what the software is doing, but perform some quick manual checks also. So never blindly rely on software. All right. And more so for the reinforcement values, as I just told you, there are some problems that the software have, both ETABS and STAT. So it's best to see what the software is doing and just do some quick manual checks also. These manual checks you can perform on Excel sheets. You can make some Excel sheets on your own, or then do the calculations manually, whatever you prefer. Okay. All right. So this was Engineer Amok Deshpande from Nagpur. Next question is from Engineer Vinayak from Yadgir. He is a working professional. He is asking, what is the lateral torsional buckling? I think for this you need to understand a few basics. Lateral torsional buckling only happens when we apply moment in major axis. How? Example with image. I think this. Let me see if I have some image about it. Just give me a minute. So I have just tried to bring one image of lateral torsional buckling. I have sent image in WhatsApp. If I apply moment in major axis, the I section buckles upwards. No, no, no. I think you are getting confused. See this here, what we have done, we have applied the load from the top on this top flange. Okay, and this is the bottom flange. And we have applied the load from the top. So what's happening? In fact, you can try doing it on your own also. You just take a piece of paper and just bend it like this. Just bend it like this and then try to apply flexural loads. You will see the top flange in this case, which is under compression, just buckling out of the plane. Okay, so this experiment even you can do on your own by just taking a piece of paper and folding it, applying flexure as if it were a beam. So you will see the compression flange in this case, which is the top flange, will undergo buckling. Why is it undergoing buckling? Because there is a tension in this flange, there is a compression in this flange. So because of the compression, it tries to buckle. Now why it tries to buckle in this manner? Because let's say this is the compression flange, tension flange. So this flange, for this flange, this axis YY is the weaker axis. It offers less resistance. Therefore, this flange will try to buckle about the weaker axis YY. Okay. So although the moment was about XX axis, we had applied major axis moment. The buckling in the compression flange, you will notice, is happening about the YY axis. Okay. The buckling in compression flange happens about the minor YY axis. So that's why if this buckling happens, if this buckles, the compression flange buckles, what happens? Because this section, the top flange has buckled, This also leads to a twist. So there is an associated twist with this compression flange buckling. Therefore, this is called as the lateral torsional buckling. So why we are calling it the lateral? Because movement was about the major axis XX and the buckling was taking place about the minor axis YY. Therefore, we are using the term lateral. Why are we using the term torsional? Because this buckling of compression flange is also associated with a twist of the cross section. So therefore, we are calling it torsional and buckling. So therefore, this is called as the lateral torsional buckling. Okay. So the same thing if we try to do for section, and if we try to apply moment about YY axis, then what will happen? Then this portion, let's say, is in compression if the moment was sagging, and this portion is in tension if the moment was sagging. So now if this member tries to buckle, it is being held together by this web. Okay, and this time the web has its major axis. So if this flange tries to buckle, this portion of the flange if it tries to buckle, it is being resisted by this web about its major axis. So it won't let the web to undergo buckling, and no twisting will also take place. So therefore, we say that there will be no lateral torsional buckling effect in beams when the moment is about minor axis. Okay, so that is the basis of all our calculations and all the design standards also. So whether you look at the Indian standard or the American standard or European standard, whichever standard you look, you will always see that no lateral torsional buckling is considered when the moment is about the minor axis. Okay, and lateral torsional buckling is only considered when moment is about the major axis as shown in this figure. So I hope this is clear. So this was Engineer Vinayak's question. Now we move on to the next question that has been asked by Engineer Dinesh from Tamil Nadu. He is a working professional. He has put a long question. Let me just paste it over here. So this is Engineer Dinesh from Tamil Nadu, and he has shared some images also. So I'll also paste the images over here. So one of the images he has shared is this. The other image shared is this. I hope my voice is audible. Let us look at the question. I have designed a steel building in which I have used ISMB 350 for 15 feet span supported on web face of column of ISMC 400 front to front. But the image here shows a box section. Here he is writing ISMC 400. Okay, I think maybe instead of making a uh, channel section box, he has made a hollow section over here. Let's see what the question is. Beam has a utilization ratio of 0.6 and column has this. Since client wants bolted connection for future reassembling work, I have a beam with moment of this at support and connection should be fixed above steel beam. 100 decking sheet will be provided. I modeled bolted connection in Idea Statica and the result shows column plate elongation is 30, which is greater than 5, showing column has failed. Suggest me connection arrangement for beam to column with bolts achieving fix for beam moment of 140 kilonewton meters so that column plates will pass. No, so in this, my first thing is what I understand from your query, that you were having a channel box, but somehow you have not modeled it, and instead of modeling a channel box and providing plates over here, you have tried to model a box section. So this is the first inaccuracy that you have committed. If you don't take the same section as you want in your actual design, then the results will not be appropriate. So my request to you will be that if you want to take, or if you have taken rather channels, you should model channels in Idea Statica also. Otherwise, results, you won't be able to fully rely on the results. What I understand from your question is that you have a box shape front to front like this, and you have put plates over here, batten plates, let's say, and to these batten plates you are connecting a beam. This is what I have understood from your question. This is the plan view. Okay, so this is your column, ISMC 400 box, whatever, and then you have your beam, which is ISMB 350. I hope this is the correct understanding I have got. Now this connection you want to make it rigid. Now the first point is that it will be very difficult for you to make a rigid connection with this type of a arrangement, because remember that your beam is getting connected to a batten plate. So these batten plates you will provide at certain intervals. So here you are providing a batten plate and then trying to connect beam with this batten plate. So first of all, making a rigid connection will be difficult for you, and I will suggest you not to do it. Rigid connection will be difficult in this case. So first thing I'll suggest you is not to do such a connection, because practically it will be difficult for you to do it in this configuration. Okay, so even if you want it bolted, that's fine, but do not go for a rigid or a moment connection first thing. So you try and do a shear connection. When you will do a shear connection, accordingly you will have to give releases in the model also. So you give releases in the model at the beam start and ending points. Okay, do that thing, give a shear connection. Maybe your sizes, you may have to look at these sizes again, because since you will change the connection arrangement, your utilization ratios may also change. So, oh, okay, it is other way around, Mr. Hiren Desai is suggesting. ISMC 400 flange connected front to front. No faceplate. Okay, so Mr. Hiren Desai is suggesting that the connection is not like this. But if I am looking at this image also, I don't know. I was treating, okay, so if we were to listen to this comment, as per this comment, what Mr. Hiren Desai is suggesting, that ISMC 400. Okay, so you mean to say that this connection is like this. So this is his channel, and then these are his faceplates. Is that what you're saying? So it's not clear from this image actually, because this image, so as per your understanding, this is 400. I was treating this dimension as 400. Anyway, so it's not clear from the question how actual connection is happening, and this image is also adding to some confusion. So is this what you're saying? Okay. So even with this arrangement, it will be slightly difficult to go for a moment connection because finally it is connected to this web. Okay, it is connected to this web of the column ISMC 400 column, and since the web is not very strong element, it is not suggested for you to go for a moment connection over here. So my suggestion to you will be to not go for this, go for a rigid, sorry, do not go for a rigid or moment connection, go for a shear connection. It will mean that you will have to provide end releases in these beams in your analysis model. Accordingly, you uh, may have to revisit these sizes also. You may have to check the deflections also. So do all those things and then design the connection. In that case, connection will be simple. You can just provide a web cleat connection in this case and just provide a simple shear connection. So my suggestion will be don't go for a moment connection or a rigid connection, and just go for a shear connection. Okay, so Mr. Hiren Desai is suggesting that flange is connected without any gap. So what he is trying to say is that there is no gap also over here. Connection is like this, back to back, front to front, like this. Okay, it becomes box. But still, don't go for a shear connection in this case. Sorry, don't go for a moment connection or a rigid connection in this case. Okay. The problem is that see your ISMB 350 flange width is what, how much? Can someone check? I think it will be 140, I guess. I'm not sure. Flange width for ISMB 350. Someone may just check it. And over here, this dimension is 400. So essentially, you are relying on just the web plate thickness, and therefore it will be difficult for you to make a rigid connection or a moment connection over here. Okay. So go for a shear connection. In depth 5677 is asking, is side plate moment connection possible? There are some, so he is asking about something like arrangement like this, where this is your channel box. We are assuming that there is no side plate, and this is plan view I'm showing. This is your ISMB 350. So this has a certain width. I think it is 140 for ISMB 350 member. This is 400. So in fact, it will be smaller. So he is asking side plate moment connection means somehow can I make a side plate like this and then try to make a moment connection? It will again be difficult to have a moment connection like this, although there are some suggestions given in AISC 358 for these side plate moment connections, but it will be difficult for you to do that. So not recommended. And many times what will happen that these sides will have some other beam framing into it. It might be having some different beam framings into it. So then if there is already a beam framing, again making a plate over here, providing a plate over here may not be feasible. Okay. All right. So do a shear connection and provide end releases. Reanalyze the members. Maybe if needed, you may have to increase these sizes, and then accordingly for shear. just do a shear connection. All right. So this was engineer Dinesh from Tamil Nadu, and these were the questions we had on the Google form. Let me just see if there are questions on the email. If there are any questions in the live comments, live audience, we will take it. So if you have any queries, you may just type in your queries. So on the email, there are no queries asked. That's good. Yeah. Good. So there are no queries on the email, and in the Google form also we have taken up all the queries. So if there are any questions on the live comments, we will now take them up. Otherwise, we will close today's session. Yes, please. Any queries on the live comments? YouTube live comments? Mr. YY is asking how long it takes for career transition from RCC to steel structures with 4 years of career break. I don't know how long it takes. Career break should not be a problem, in my opinion. Career break is not a problem. If you have enough knowledge of steel structures, then uh, I don't think it should be a problem for you. Just take a job where you are having or where you get exposure to steel structure design, and I should think of I should think you should be able to easily transition. He had experience of intermediate experience. I had experience of working in Tekla modeling industry. So if you are working in, let's say, Tekla modeling, and if you don't have knowledge of steel design, then first you need to do steel design, understand steel design, work on it, and then find a job where these things are practically being done. And I think if you start learning it on the job, things will not be so difficult for you. Mr. Dinesh Tamila Rasan is asking, can we, in continuation to the earlier question, can we release partially for beam column connection? Yeah, you could do it, but then you will have to calculate the stiffness, how much partial release you can do, and then those stiffness values you will have to put. So I won't suggest you doing it. Best suited thing in this case will be to go for a shear connection. Uh, for the type of column that you are having, best suggestion will be to go for a shear connection. Okay. Yes. So anything else? Any other query, please? Mr. Hiren Desai is asking, any good reference book showing different possible connections between different type of members like I sections, C sections, angles, hollow sections, etc. I'm not sure of good reference books. Uh, I have only read steel design book by Dr. Subramanian sir. That is the only steel design book I have ever read. And one book by Negi, P.N. Negi. P.N. Negi, or some initials I'm forgetting. So I think these are the two steel books I have read. Textbooks I'm saying. So I'm not sure about authors other than these two. If any other people may comment on this. Alan William, Mr. YY is saying. So I'm not. I have never heard about him. I have never read him, so unable to comment. But I'm sure there must be some good references available. But if you, I think you may look at some references from Zamil Steel, for example. Reference from Zamil Steel. It shows a lot of good connections. It is mainly for PEB type of systems, but it will help you in understanding some basic connection types that they do for PEB. But if you PEB means built up I sections that they do. But if you understand those, I think it will be helpful for you in other work also. In addition, you can refer to the design guides that AISC have. Okay, AISC design guides. So there are some 20, 40 AISC design guides. Those give you a lot of good idea about how the connections are to be. I mean, they talk on different aspects. There are good pictures, uh, and they cover different topics. So for hollow sections, for example, there is an AISC design guide number 20 something. I'm forgetting its number. AISC design guide 24 for hollow sections. 20 design guide number 24 is for hollow sections. Okay, hollow section connections. Then there are other design guides. So overall 40 design guides. A lot of them are very helpful. So these can be one of the good references for you to refer to these connections. We have done different courses also where we cover a lot of different connections. So maybe that is also helpful. That may also be helpful for you. And I think with uh, more projects that you do, you will understand more type of connection possibilities. LS Negi, correct. As Mr. Selvan is informing us, LS Negi was the book, and book by Professor Subramanian sir. So I think these are the two books that I have referred to. Beyond that, books I have not referred much. Yeah. Design guide for buildable steel connections, Singapore Steel Structural Society related to this. So these are additional documents that Mr. In-Depth is providing us. Yeah, all the AISC design guides are quite helpful. 40 in number, so you can refer to them. Not just connections, they cover different aspects of steel design. I think it will be very helpful for you to uh, go through or refer to them. Okay, all right. Anything else? Okay, so I think we do not have any other question. We don't have any question on the Google form also. So then this is it for this week. You can continue to paste your questions on the in the Google form. The link for the form remains the same. Oh, non-technical query. Mr. YY is asking non-technical query. Which writing pad do you use for presentations? Uh, Really interesting illustration. Appreciate your efforts, sir. Oh, thank you. So this is XP pen. This was suggested to us by one of our previous participants. This is XP pen. This is a brand name, and the model that I use, model number I am unable to recall, but it had costed me somewhere around 6500. uh, I had bought it 5 years ago, so I'm not sure about the current pricing for it. This is the brand name XP pen, and it comes with a writing pad. So it's a this type of a thing. I'll just show you this type of a thing. So the size is A4 size it is. So there are some additional more features also that come in higher priced models, but I think for writing work this is enough. So this is A4 size, let's say in a landscape orientation. Okay, and so whatever you write, basically assume that it is being written on the screen itself directly, and then it comes with this type of a pen, this, and with this type of a nib. So this nib, due to continuous writing, it just deteriorates or finishes off, and then they have provided multiple other nibs with it. So you can just add or change the nib, replace the nib, so to say. And then this pad is connected through a USB cable to the computer or laptop, whatever. Yes. So it's a useful tool actually. So not only over here, but we use this writing pad for our sessions also, and even in our project meetings also with clients, online meetings. Uh, if we have to explain something to clients online, then this is a good way of making sketches or just making notes or whatever. Yeah. And this is Microsoft OneNote. The screen that you see is of Microsoft OneNote. Okay. All right. Anything else? Okay then. So this is all. You can continue to paste your queries in this Google form. As you all know, once every week we conduct this session, but the Google form remains the same. So throughout the week, whatever queries or questions you have, you may put it over here, and during these live sessions we will take up your queries. And then if you want to connect with us on WhatsApp, this is the link. So you can just click on this link and connect with us on WhatsApp. Okay. All right. So then this is all for this session. We will see you next week now. Thank you so much. Bye bye.